Identify the amplitude and period. What is my amplitude, guys? 2/3. Very good. How do you find the period of a sine and cosine graph? What's the formula?
It's 2 pi divided by
2 pi divided by b. Very good. 2 pi divided by b. Your b value is right here, isn't it? So I'm going to say 2 pi divided by 3/4. So when I divide that, it's going to be 8 pi over 3, isn't it? Because you flipped the fraction. Does everyone understand that? Okay. On this particular example, it's the problem. It says graph this. So we're going to review how to graph this. What is my amplitude? 3. Okay. My period is right here. Remember, if it's inside the parentheses with theta, you got to factor it out. But it's right there. What's my period going to be? 2 pi, because 2 pi divided by 1 is 2 pi. Is this a phase shift or vertical shift? Phase shift. That means it's going to move it right or left. I see negative, so it's going to move it opposite, which is what? Right. Very good. We're going to make a chart. We're going to take our period, and remember we divide it by 4. 2 pi divided by 4 is 1/2. Remember that top row is if we were graphing it as if it was just a period and an amplitude, okay? So I got my x coordinates. Now sine, does it start at your origin or does it start at your amplitude? Origin, thank you. Don't make me have a blood clot. Well, you said the wrong one. Come on, it was only 3 months ago. Sine starts at your origin. So we go here, then we go up to the amplitude. If you have trouble, look back under your first divider on this. Alright, you said this is the phase shift. So will I add pi over 4 to my x or my y coordinates? X, very good. So pi over 4, 3 pi over 4, 5 pi over 4, hold on, I'm sorry, I just lost it for a minute. And then, since I'm not affecting my vertical shift, I bring it straight what? Down. And then I would draw my graph. Do I need to draw my graph for that? Y'all, that's the hardest part. Do I need to draw my graph, or are y'all good on that? I'll draw my graph on the next one. I got one more example. But that would be what you graph. These would be your x coordinates, and then you go like that. Are we good on that? Do I need to graph it, or are we good? Okay. No, there's no tangents on your. Oh, by the way, all the ones that's on your test are sine and cosine. You're welcome. You're welcome. All right. What is wrong with this one right here? There's something right here. There's something right here. Turn to the back of your study guide. You see that you got 4 short answer? I think this is number 1. This is one just like the one you're not going to have multiple choice on. You got to do this by hand. Is this number 1, y'all? Yeah, this right here. I don't know where number 5 is at. There's 5 short answers. I'm going to have to look to see what number 5 is and give that to y'all. But this is one. You remember on first semester where you had those 5 short answer, and I had to send to Jeff State telling how many people master those questions? These are the 5 I got to send to Jeff State. So make sure you know how to do these 5.
So these are the same ones that are going to
I didn't say that, did I? I don't think so. I think I changed them up a little bit on here. It's very similar to the format. Good morning. All right, so on number 1 here it says graph the following trig functions. So what is wrong with this picture right here? There's a 2, and what I'm going to do with that process, you're going to do what? Factor out a 2. When you factor out a 2, guys, what operation is that? Division. So if you think about it, I'm going to say pi over 3 divided by 2. When I do that, that's going to be pi over 6 left in parentheses. Okay? Does everybody see how I got that pi over 6? That's the hardest part of this problem. Now, what's my amplitude? 5. My period would be 2 pi divided by what? 2, which is pi. My phase shift would be pi over. And do I have a vertical shift? No. Okay. Take your pi, divide it by what? 4. Remember we did that. Pi over 4, pi over 2. Well, I'll start with 0. 3 pi over 4, pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 is 2. So I got that. Now, cosine, does it start at your origin or at your amplitude? Amplitude. Phase shift. What does that affect, guys? Your x. Very good. So I'm going to add pi over 6 to each of those. What's the common denominator? Pi over 6. That'll be 12. 3 pi. Is that 5 pi over 6? Somebody put that in the calculator. 3 pi. 5 pi over. 5 pi over 12. Okay, y'all got calculators. Come on, help me, y'all. Come on now. Pi over 12. Okay, thank you. All right. Now do pi over 6 plus, pi over 2 plus pi over 6 for me. Pi over 3. Gracie, will you hand me a calculator there, please? Guys, all I'm asking you is type these in the calculator. Some of y'all are just sitting there with me, so I'm just going to do it. Thank you. $11 pi over 12. Thank you. Thank you. Next one. Okay. Pi over 3. Okay, thank you. Next one, 23 pi over 12. And the next one, 13 pi over 6. Please tell me everybody knows how to do that in calculator. Thank you for the ones that responded to that. Are there any questions on reviewing graph and sine and cosine? Guys, I'm just going to tell you this. I do not expect you to just sit there and expect me to come up with the answers. If I got my calculator out, I expect you to have the calculator out. If we repeat what we just did, I will stop reviewing and you're on your own for that final. Do I make myself clear? Not another morning like that. Because I would just say, study guide. Alright. Let's turn to page 15 or less. Unit. This is like the second unit in calculus. Secants, tangents, and intro to derivatives. Calculus is founded on two principles, limits and derivatives. We talked about limits last week. Now we're going to talk about derivatives today. Before we get in our discussion about derivatives, it says, remember average rate of change, AROC. What was AROC?
It was kind of like slope, but it wasn't for linear lines.
Very good, Jack. It is equivalent to slope, but and like Jack said, the only time you use AROC when you didn't have a linear function like parabolas or cubic functions is when you were trying to find what was going on between these 2 points to try to get an average. So it is equal to the slope between 2 points. AROC is the slope between 2 points. The line through 2 points on a curve is called a secant line. If it touches it twice, it's called a secant line. Secant line. And remember, the average rate of change is very similar to slope. You have x sub 2 minus x sub 1 on the bottom. On top of slope, you have y sub 2 minus y sub 1 in the numerator. Well, isn't f of x sub 2 and f of x sub 1 mean y? So that's reviewing it. So here, what kind of function do I have right here? I have a quadratic. Very good. So could I just find me the slope to represent the entire thing? No, I have to find the what? Average rate of change between 2 points. You have to find the rate of change between 2 points because it doesn't have the same rate. Because over here it's decreasing, isn't it? Over here it's increasing. So right now we're going to find the average rate of change for these, and we're going to look at something. So right now we want to find the average rate of change between the 0.1 value and the 0.3 value. So in fact, what we're doing is finding the slope of that line, okay? Slope of that line. So let's find the average rate of change here. This would be what? F of 3 minus F of 1 over 3 minus 1. If I plug 3 in, what's 3 squared? 9. 9 plus 2 is 11. If I plug 1 in, 1 squared is 1. 1 plus 2 is 3 over 2, which would be 11 minus 3 is 8. 8 over 2 is 4. That would be my average rate of change there. This is just reviewing average rate of change. This is not the meat of our lesson. It's getting there. B, I want to find the average rate of change between 1 and 2. 1 and 2. So F of 2 minus F of 1 over 2 minus 1. I plug 2 in. 2 squared is 4. 4 plus 2 is, plug 1 in. 1 squared is, plus 2 is, get 3. Juniors, do your best on Wednesday. You are ready for the ACT. Do the strategy was done. You've learned your pre-cal. You got this. Okay. I've had juniors take it the last couple of years, and they said it's challenging. But let me tell you this: some of my juniors' best scores came off that ACT on the school. Okay. So even if it's difficult, and you walk out of there with your head spinning, some of them made their first 30 in math on that ACT. You got me? So keep your head up. Just go in there. You're familiar with the test, and you'll be fine. Okay. All right. I want you to do C right now. I want you to do C through F right now for me. You can do it in the calculator if you want to. I'm giving you about 3 minutes. Bring me that phone. Okay, that was good to cover up. Thank you. I know you just showed me the calculator, so I believe you're good. Not really. What y'all get on C? 2 point what? 25. What you get on D? Very good. E. F. Oh! What are y'all noticing there? Okay, so average rate of change, we started from like 0.1 to 0.4, didn't we? And we're slowly getting to what? What value? Yep, but right here, I'm slowly going from 1 to 1.001. What do you think this value is? It's approaching what? It's the limit, isn't it? Okay, it's the limit. Hold that idea. If we were to draw, we're going to do this, if we were to draw all the lines out for all these, what do you notice? It almost looks like it touches it one time, because that's very close together, isn't it? So by the time you get to this, are you dealing with a secant or a tangent line now? Tangent, because you're touching it one spot, aren't you? Okay. Don't let me lose you. Some we're going to get this. Yes, really close together. It says if a of x is the a-rock function, what would you guess the limit if x approaches 1 equal to? We just found it. It's going to be equal to what? 2. Okay, guess what this is called? Instantaneous rate of change. I-rock. A-rock is the average rate of change between two set points. If you want to know what's going on in that instance, right there at 1, that's called I-rock. And that's your derivative, okay? I-rock. Now you said, Mr. Fisher, what is the significance of I-rock? It is the slope of the tangent line at that given moment, I-rock. Because you just told me eventually it gets to where it just looks like one line it touches at one time, though. Okay, so A rock deals with secant line, the slope of the secant line for those 2 points. But when you're wanting to know what's happening at x equals 2 seconds, that is a tangent line because it touches one spot. It's the slope of that tangent line, okay? And that is your I rock, instantaneous rate of change. Do you see the difference there? Does that make sense? Yes. Okay, I was about to answer that question. You said, Mr. Hester, you just said the limit x approaches 1, but it looks like it's at 3. Okay, is that what you're asking? Okay. Now remember, the I rock is not the limit. I probably shouldn't have put that there. Okay. The I rock is the slope of the tangent line. That's the limit, okay? So yes, it looks like when you go to 1, it's approaching 3. I probably shouldn't have put that there, so hold on. I want you to remember, when you see the derivative, that is the slope of the tangent line, okay? The slope of the tangent line. Okay, so I got 2 here, but you said 3. You're not going to be able to see it in the graph, okay? 2 is the slope of the tangent line. Do not get that confused, okay?
Well, it's not the limit, it's the slope.
No, it's slope of the line. Very good. All right. All right. Turn to page 17. Here's the big concepts. The slope of a secant line through 2 points tells you the average rate of change. That's the A rock. The slope of the tangent line at the point tells you the instantaneous rate of change, the I rock. The graph that represents the slope of the tangent line for each point on the function is called the derivative. The derivative of f of x is written as, okay, the way you read this is f prime of x. F prime of x or f prime. And it's pronounced f prime of x or f prime. If the original function is given in y equals form, the derivative is written as y prime, or you're going to see dy over dx. That means derivative, okay? So you can see this notation, this, or this, and that all means derivative, okay? So I call the derivative the AKA slope generator. So you really want to know what a derivative is. It's a slope generator. It's the slope of the tangent line at that instance. That instant moment, the slope of the tangent line. That's your I rock. Instantaneous rate of change. Average rate of change is over over an interval. Instantaneous is at that moment, okay? The slope of the tangent line at that moment, okay? So, here's the formal definition for a derivative. It says let y equals f of x, denoted function f. The derivative of f at x, denoted by f prime of x, reads f prime of x is defined by this. This is the formal definition. This does take a little while. I'll show you shortcuts on Thursday, Friday, but that's what we're going to be practicing today and tomorrow. So, the direction here says find the derivative of f at x. That is, find f prime of x. So I'm going to find the derivative, and then I'm going to find the slope of the tangent line at these 2 points. So once I find my derivative, that's the slope generator. How will I find the slope for these 2? Take that and plug it in into the what? Derivative. Does that make sense? So I'm going to find the derivative, take these 2, plug it in. Okay, so how do I find the derivative of this? Okay, you'll need some room for this because this is a long process. We're only going to get 2 examples in probably. Alright, I'm given this function f of x equals x squared plus 3x. and I want to find the derivative by using the formal definition. If I look in the formal definition, I have a limit as h approaches 0 of f of x plus h minus f of x over h. Well, I got to find f of x plus h. How would I find f of x plus h using this? Take x plus h and plug it in for what? X, wouldn't I? Because you know, if I find f of 5, I'll take 5 and plug it in for my variable, wouldn't I? So I'm going to take this, x plus h, plug it in. So I'm going to find f of x plus h first. I'm going to plug that in. When you FOIL that out, you get that value. X plus h squared is x squared plus 2xh plus h squared.
So what did you do right there?
I took what's inside the parentheses here, plugged it in for my variable. FOIL that, that's x plus h times x plus h. I get x squared plus 2xh plus h squared, then distributive property. Now I'm going to do this part, f of x. I take x, I plug it in, it does not change it. Now I'm ready to use this formula here. The limit as h approaches 0, plug this in. Minus this formula. And I put this in parentheses because what does this minus do to everything? Changes. The nickname of this formula is called the difference quotient. Difference quotient. But it's the original formal definition of a derivative. And that's what our learning target was today, is I can find the derivative of a function using the formal definition. This is the formal definition. Okay, I'm going to try to simplify this. I will give you a little hint here, guys. At this stage in the game, what can cancel out? And 3x. When you get to that point, guys, everything that doesn't have an h should cancel out. If it doesn't, then we might have a slight problem. Okay, you need to go back and look at your work. But at that point in the game, everything that doesn't have an h should go out.
I just got a question about like how you find f of
X plus
h.
Okay. You plug it in to the original problem, plug x plus h in. Just like if I found f of 3. Wouldn't I just plug 3 in for x? Do you see how I plugged that in, buddy?
Yeah.
Okay, do you understand how I got that? I FOIL that. X plus h times x plus h. Does that make sense now? Okay. Now, let's think about this now. If I was to do my limit, I've tried direct substitution first. H approaches 0. I can't do that. It's a no-no, isn't it? So what toolkit strategy do you think we can do here? Factor. That's what you can do most of the time. Factor. So on the top up there, I'm going to take out an h. That leaves a what happens to these h's right here? Now plug 0 in. I get what as my derivative? If I plug 0 in for h, not x, because h is approaching 0, that goes a weight on it. I'm left 2x plus 3. That's my derivative. You said, Mr. I was going to plug 0 in for every variable. Just do this h. H approaches 0. Your h is going to go away, guys. That's the point. So you're going to be left with 2x plus 3. And that is your derivative. That's your aka slope generator. That right there can be used to tell you the slope of any tangent line at any instance on the graph. Instantaneous rate of change. So your formula is 2x plus 3. Now what did it say it wanted you to find? The I rock at what? -2. So if you wanted to write it like this, let's do this. That is the derivative symbol, f prime. So I would be looking for that. That's your derivative. Yes.
Where's the other picture?
Once you do direct substitution, yep. Now I'm going to find f prime of negative 2. Watch how I write that. F prime of negative 2. Negative 4 plus 3 is negative 1. So at negative 2, the slope of your tangent line is negative 1. That's what that means. At x equals negative 2, the slope of your tangent line is negative 1. Does that make sense? Okay? That's your IROC at that very moment. Now f of what? Two times negative, this will be 0. Now I'll give you a little hint. This helps you predict something right here. At this point in the graph, you see it's a negative 1, the slope of the tangent line. What do you think the function's doing? Increase or decreasing? Decreasing. The function's decreasing. What if it was positive? That means your function's what at the moment? Increasing. What do you think 0 means? Okay. You remember when you had like max to min points when it's turning from increasing to decreasing? That means something's going on there. There's a turn going in the graph. Okay. Does that make sense? Okay. Let's do one more. The h, once I did direct substitution, h approaches 0. That's 0. Yeah. Alright. Number 6. Alright, first thing I'm going to do is find f of x plus h. X plus h squared is x plus h times x plus h. So you have to go to the side. I can do that in my head, but if you can't, you need to go to the side. So that's going to be 3x squared plus 2xh plus h squared. So I plug x plus h in because that's part of my formula. Fold it, and then distributed 3 and distributed 12. When you understand those two things, look up to me. I don't do anything else. I just want to make sure we got those two steps down. Now, I'm going to take those two things, guys, and I'll put it in my formula. The limit as h approaches 0 of this minus this all over h. Now, if I did it right in a minute, what's going to all have to cancel out? Everything that doesn't have a what? Very good. So let's write that out. That minus changes everything. Oh, and And that did, so I know I did it correctly. Now, I take my direct substitution, plug 0, and I still have a problem, don't I? So what toolkit strategy am I going to do? Factor. You can factor a 3 and an H out. Yep. Need some I can't answer that right. Hello? No, he's absent today. Yes. All right. Be honest with you, really, as long as you just factor the H out, because 3 is not the only thing that's going to cancel out your H's. But if you factor 3 out, it's fine. We go ahead and do that. All right, that leaves me 2x plus H plus 4H plus 4 all over H. What happens to these H's right here? They cancel. So I'm left with the limit as H approaches 0 of 3 times 2x plus H plus 4. You don't have to factor that 3 out. Yep, just factor the H out. I take a 0, I'll plug it in. That just leaves me what? 3 times 2x plus 4. Because that 0 makes that H go away. I'm going to redistribute that 3 because it just looks weird. So your derivative is 6x plus 12. So f prime, that's your derivative. That's your AKA slope generator. So at any point in the graph, you take the x value, plug it in, it tells you the slope of the tangent line. The tangent line. When I show you how easy it is to do the shortcut, you'll think, my God, this fish, because that problem right there could be done in 2 seconds. But I'm making y'all appreciate it after you go through this for a couple days. Parker, you remember the tricks. Alright, so if I asked you to find where x equals -2, f prime of -2 equals 6 times -2 plus 12, that gives me 0. So what does that mean is going on a graph right there? We're doing what at some point? Turning. You're going from increasing to decreasing. And then f prime of 1. 6 times 1 is 6 plus 12 is 18. That means it's increasing. What time is it? What time we get out? Hold on, let me turn the page, next page. Just want to say something. Alright, so your notes on that I'm going to leave you tomorrow. The homework tonight practices this, but your homework, your video will go over these 4 problems and do the next 2 examples on the next page, okay? And then you will have an assignment with that video, which practices this more, okay? Is everybody good? Okay, thank you. And I also will do some more semester exam review in the video, okay?